Hey grade 9 students at St. Paul American School Clark, welcome to today's Explainer. We're diving headfirst into Geometry Unit 5, Lesson 5, Sine, Cosine, and Tangent. I am honestly super thrilled to guide you through this, because we're about to unpack some of the most powerful, absolutely fundamental tools in all of geometry.
Okay, so here's our roadmap for today. First, the objective. Second, the core concepts of sine, cosine, and tangent. Third, a worked example. Fourth, a misconception check. Fifth, a formative check. And finally, number 6, a quick recap.
Let's get right into it. Section 1, Objective.
Our main goal today is to really understand and then apply the foundational trigonometric ratios, sine, cosine, and tangent. But look, we aren't just memorizing formulas here. We want to grasp exactly why they work, which all boils down to the math behind right triangle similarity. And why does this actually matter to us? Well, these exact ratios are the secret to how engineers construct massive bridges, how game developers build 3D worlds, and literally, how we measure the distance to the stars. It's totally fascinating stuff. Moving right along. Section 2, Core Concepts. We're talking sine, cosine, and tangent.
So here is the big secret, our core anchor for the whole lesson. Because of similarity, side ratios in right triangles are unchanging properties of the angles themselves. It doesn't matter how large or small the triangle is. Even if you have two triangles that are vastly different sizes, as long as their angle measurements are exactly the same, the ratio of their corresponding sides will be identical. These ratios are tied 100% to the angle measure, not the size of the triangle.
But hey, before we crunch any math, we've got to be extremely precise with our vocabulary. We need to make sure we can always pinpoint the hypotenuse, the opposite side, and the adjacent side relative to a specific angle. The hypotenuse, always the longest side, directly across from that 90-degree right angle. But opposite and adjacent, well, those depend entirely on which acute angle you're currently looking at. Opposite is the leg all the way across the triangle from your angle, and adjacent is the leg that forms one side of your angle. Precision right here is everything. All right, so the first of our 3 historically named ratios is sine. We define this as the length of the opposite side divided by the length of the hypotenuse. Fun little fact for you, mathematicians long ago agreed on these names, which are actually translations of Latin words. So whenever you see sin abbreviated on your calculator, just think, opposite over hypotenuse. Next up is cosine, which connects the length of the adjacent side straight to the length of the hypotenuse. If you've ever found yourself wondering where the word cosine even comes from, the co part actually refers to the sine of the complement. But for our core definitions today, just lock in the fact that cosine is the ratio of the adjacent side over the hypotenuse.
And finally, we have tangent. Tangent gives us the ratio of the length of the opposite side to the length of the adjacent side. You might notice something kind of special here. Tangent is the only one of our 3 primary ratios that doesn't use the hypotenuse at all. None. It strictly compares the 2 legs of the right triangle.
Section 3, Worked Example. Let's actually apply this math.
Take a look at this right triangle. We're going to focus entirely on angle x, using its specific side lengths of 1, 3, and the square root of 10. Imagine you are literally standing right there at angle x. If you look straight across the triangle, your opposite side is 1. The leg right next to you, the adjacent side, is 3. And that longest side, the hypotenuse across from the right angle, that's the square root of 10. See how brilliantly this works out? We just plug those exact side lengths straight into our definitions and boom, we get the exact sine, cosine, and tangent ratios for angle x. Since sine is opposite over hypotenuse, the sine of x is simply 1 over the square root of 10. Cosine is adjacent over hypotenuse, making the cosine of x 3 over the square root of 10. And tangent, opposite over adjacent, which gives us 1 over 3, or 1/3. It really is that systematic and direct.
Up next, Section 4, Misconception Check. Let's avoid some common pitfalls.
Okay, this is an absolutely crucial point. Remember that sine x is just an abbreviation for the sine ratio of an angle measure. It definitely does not mean sine multiplied by x. You can't just divide out the x algebraically like it's a variable you're trying to isolate. Instead, think of sine as a label, asking a specific question. What is the opposite over hypotenuse ratio for this particular angle?
Also, I know everyone loves a good mnemonic trick like SOH CAH TOA to remember formulas, but the Ohio Department of Education hit the nail on the head here. Those tricks are never a substitute for truly understanding the underlying concept. If you just blindly memorize a chant, you completely miss out on the beautiful geometric truth that these ratios only work because similarity perfectly preserves side proportionality.
Section 5. Formative check. Time to test your knowledge. Looking at this exact same triangle, I want you to take a second and mentally calculate the sine, cosine, and tangent ratios for the other acute angle, angle y. Go ahead, shift your mental position over from angle x to angle y. Ask yourself, what's your opposite side now? What's your adjacent side? The hypotenuse, of course, stays exactly the same.
All right, let's check your work. Did you notice what happened? By simply shifting our perspective to angle y, our opposite and adjacent values literally swapped places. So from angle y, the opposite side is now 3, and the adjacent side is 1. That makes the sine of y 3 over the square root of 10. The cosine of y is 1 over the square root of 10, and the tangent of y is 3 over 1, or just 3. Check out that beautiful symmetry. The sine of y is identical to the cosine of x.
And that brings us to Section 6. Recap. Our key takeaways.
Let's lock this in. Remember, these three fundamental ratios work precisely because similarity ensures that side proportionality remains totally constant for any specific angle measure. Once you identify your target angle, you label your opposite, adjacent, and hypotenuse. Then you just apply the ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we know that as an acute angle gets bigger, its sine increases while its cosine decreases, right? Well, consider this. What mathematical limits are actually hit as that angle pushes right to the very edge of 90 degrees? It's a wildly fascinating question that pushes the boundaries of everything we've just defined and paves the way for higher-level mathematics. Thank you so much for joining me for this explainer on the foundational trigonometric ratios. Keep visualizing those triangles and definitely keep questioning the math around you.